Okay, student, here we shall see about Kirchhoff's laws. So this Kirchhoff's laws is actually very important, especially when you solve the numerical problems which is based on the complicated circuit. So this law actually consists of two laws. Number one, it is Kirchhoff's current law. In short, we write KVL. And sometimes this law, it is also known as the junction rule. Junction rule. So first let us discuss about this law. Alright. So this law, it says that the algebraic sums of current meeting at a point or at a junction, it is equals to 0. For example, here let me consider 4 wires, okay, in this figure. Let's say these are the currents that are flowing through different wires. So as you can see in this figure, this current I1 and I2, they are right coming towards the point O, or they are entering the junction, whereas current I3 and I4, they are leaving the junction. So what happened is, if you you write the mathematical equation of this Kirchhoff's law, right? Because this law says that the algebraic sum of current meeting at a point is equals to 0. So therefore, this word algebraic here, it's very important, because here we have to consider the sign convention like plus and minus. So therefore, we will imagine like for those current which are entering the point, we will take the sign as a positive. So like I1 and I2, they are entering the point O, so therefore, these currents will be positive. And those current which are leaving the junction, like I3 and I4, right, will be negative. So this algebraic sums of current, when you write it mathematically, it means I1 plus I2 plus current I3 is minus I3 plus minus I4. This is 0. Or I can also say that this I1 plus I2 is equals to I3 plus I4. So what is this I1 plus I2? I1 plus I2, they are the currents which are meeting the point O. Whereas I3 and I4, they are currents that are leaving the point O. So hence, I can say here that the sum of current entering a point or a junction is equals to the algebraic sums of current leaving the point. So this becomes a new definition for Kirchhoff's current law or junction rule. Okay, apart from this, when you look at this equation, sum of currents entering a point is equals to sum of current leaving the point. So this means that, because current is actually the flow of electric charge. So therefore, if the sum of current entering a point is equals to the sum of current leaving the point, it means that the amount of charge that are entering the point, it is equals to the amount of charge that are leaving the point. So hence I can say that This law, it is a law of conservation of charge. So please remember, in exams, if they ask you like multiple choice, this Kirchhoff's current law, it is based on which law? Your answer is, it is based on the law of conservation of charge. Okay.